So after reading the word problem, let's jump right into the first part. How long will it take for the rock to hit the ground? We have a function that tells us the height after a certain amount of time. We just need to make a replacement here. This is going to be a 30 that we plug in for v sub 0. So the height of the rock is negative 30 t squared plus 16t. So how long will it take for the rock to hit the ground? The rock is 0 feet off the ground when it's on the ground. So we plug in a 0 in for h. And then we have something to solve here. This is a quadratic, so you could use the quadratic formula if you'd like, but this is a special type of quadratic where factoring out what's in common is going to help you, because from both of these, you can factor out a 2 and a t. That leaves you with negative 15t plus 8. And the reason why we do that is because now all I have to do is take each factored piece and find out what it takes to make that be 0. Because if you can make this parentheses be 0, then 0 times whatever that is will equal 0 and give you a true statement. So we take that parentheses, set it equal to 0, and then just solve each one like a normal equation. This one you get t equals 0. This one you should get t equals 8/15. So this is the time when we start off the throw. This is the time when we've hit the ground again. So how long does it take for it to hit the ground? It's 8/15 seconds. Not even a whole second. So part B, assuming that Jessica is standing on a chair 4 feet up. So what's happened is her height function is still the same. It still follows the same trajectory, except now plus 4. It's lifted 4 feet into the air. What is the maximum height of the rock? And to find the max, you should probably know how to first visualize this quadratic. And A dictates the shape of the quadratic. If A is positive, the quadratic looks like this. But in our case, if A is negative, the quadratic looks like this. So right here is the maximum point of that quadratic. That's called the vertex. If we can find the vertex, we can find the maximum height of the rock. And the x-coordinate of the vertex is found by using this formula. X equals negative b divided by 2a, where a is the coefficient of x squared, or t squared in this case. B is the coefficient of t, and c is the number hanging out by itself. So I've got negative 16 over 2 times negative 30. So as a decimal we've got 0.26 repeating. That's the x-coordinate of where we reach the maximum height, but or not in this case the t-coordinate. We want to find out the h, so you need to take this location of the vertex and plug it back into the function. So I plugged in the location that we found, 0.26 repeating, into the function. And with a calculator, I'm going to do 0.26 repeating squared, then multiply by negative 30. Then I'll add this. Just realized there's something we need to add over here, because they're standing 4 feet up. So we need to have that plus 4 in the end. So when you add this term with the calculator to this term, you get 2.16 repeating. And then add that 4 extra feet that they're standing up. She's throwing it measly 6.16 repeating into the air. So that's it. 6.16 repeating feet into the air. That's the maximum height, because that's the vertex. That's the y coordinate of the vertex.